Today's session, we will move into a deeper technical talk. And this session will be the heart of MediaWiki, where we will be talking about databases and SQL, because every Wikimedia tool lies one it all lies on a critical step, that is databases, and we will be talking about that today. So today's session is very important. If you want to build a meaningful tool, optimize performance, or work on real MediaWiki tasks, you must understand how data is structured, queried, and optimized for that. Before going further, I wanted to show you a small story.
My name is Vrijraj. I'm from Badme, Rajasthan. I'm the first engineer in my family of teachers. I like to build technologies, but I guess the teaching works was into me too. When I became a JDG organizer, I realized that teaching at scale is not easy as just teaching, because there are a lot of overhead when running a community. So I decided to try and build open source web platform to help developer community run smoothly. I went to the drawing board. With the help of my team, we set out to build Aura. Aura is a web applications to organize and manage the developer communities. Our team met together over Hangout and developed the features of Aura. This wasn't easy, but we hacked through all the tasks until we were confident Aura can be useful for everyone.
I just played a little part where I would just test it whether it's working or not, and I was not into communities at all. But then when I came out of my comfort zone, it feels like people are doing it together. So why not me doing it with them?
When GDG DevFest India was coming up, the Google ecosystem team asked if I would be able to use the Aura codebase to create an event platform to manage DevFest India. That was a big deal because we had only 3 days to complete, and the platform has to support 40,000 users. They had high expectation from us, and we were eager to deliver.
We work together, we share our feedbacks, even if it's negative or positive. Whatever happens, we have each other's back.
Today, there are over 100 communities in India using Aura, and recently I was approached by communities globally who want to use our web application to scale up their own country.
I think doing what makes you exciting will make others know about what you're doing. I made an impact on others' life, and that is a very good feeling.
I made an impact contributing to the ecosystem. That was a good feeling. That was the last word. So this is how the community works, and um, you create an impact by your work in the community so that other people can also get benefit of it. Do you wish to meet Vrijraj? Anybody? Cool. We have Vrijraj today with us. He's a Google developer expert for Firebase and machine learning. He's also a DevRel head for DevRel on in Lematic. So Vrijraj will be talking about databases, SQL, and more things. So yeah, Vrijraj, the platform is yours. Please go ahead. Hey.
Yeah. Just want to quick check. Am I audible?
Yeah, you are.
Okay. Let me share my screen. Okay. So, hi everyone. Thank you so much, Ankit, for inviting me once again in this program. And this is, one of the best time, to engage with the participants who are more active in the communities and they are building the solutions and all. So, hi everyone. So, my name is Vrijraj, and you know, apart from like if I talk about the community point of view, so I'm a Google developer expert for Firebase and machine learning part, and also I'm an advisory board member for the Google for Developers, and also I'm a mentor for Google for Startups. So if you're building any startup or if you're building any solutions, so I can help you in terms of how we can build a product in terms of AI integrations, the scalable SaaS applications, and all. And in terms of professional point of view, so I'm a CEO and for TechFormand and StepWik, and I also lead the developer relations team at Climatic.ai. So feel free to connect with me or my website, or you can, just go to the Twitter and you can find my, username as Vrijraj. And if you have any questions, so I'm happy to help you, in terms of technology point of view. So let's get started. Apart from these things, so like this is more about like what I do apart from the professional life. So I'm a traveler. I used to travel a lot in terms of multiple countries, continents, and all. I'm also a scuba instructor, and also I'm certified remote pilots and all. So let's get started. And before we jump to the sessions and what we can say the hands-on part, I just want to ask some questions. So you can raise your hand or you can mention in the chat section. So how many of you are students? Okay. How many of you are from first year of your the bachelor degree or maybe the college part? Second year. Okay. So let's change the emoji. Like let's say heart for third year. Okay, that's great. And what about the final year part? Like you can, use any other emoji apart from these things. Okay, it's thinking, like looking for a job and all. That's great. Okay, so how many of you have expertise or let's say experience into the database part, or have you ever created any website or use any database? Okay, that's great. So that's good. So let's get started. So I'll try to make the sessions more interactive, and also I'll cover some use cases. So rather than focusing on the content, I also cover the use cases. Like let's create a web applications where we will use the database, and what type of database we can use, and what would be the best practices that we can apply while implementing that particular database and all. So in this particular talks or the sessions, so here I will start the basics, the fundamentals, like what is the web ecosystem right now in India. And then I'll talk about the web fundamentals, like how we can, build a website, how we can, create web applications, and why we need a database, and how we can, use the concept of database in our web application development. And then we'll share some use cases, like we'll cover one use cases. Let's jump to, let's say, to-do applications. So let's say if I want to create a to-do applications, so how we can design the database with SQL, and how we can make more complex logic. So if I talk about like in our region, like the country India, it's a very big opportunity. So right now we have 932 monthly, millions monthly active users are here in India. And there are somewhere around like more than like 932 millions monthly smartphone user devices are here. So we have a lot of opportunities. Like opportunities can be anything. Like you can create a mobile applications, you can create a web applications, and you can build a startup, you can build your solutions, and you can share with the communities, and you can solve the problems and all. So, and if I talk about like the internet, like which is the foundations, like how we can access the informations. So we can we are accessing the informations through these kind of cables. So this cable is called as like the submarine cables, or what we can say the fiber opticals or fiber optics cable. So if you see the link, like let's say submarinecablesmaps.com, it's arrive the locations for how you are going to access the informations. So generally, let's say if you are in India and I have some informations, or if I talk about I have a server in my US locations, so I can see the map informations, like how my information is going to come through these kind of cables. So it's a live map. So you just need to go to the submarinecablesmap.com, and then you can see the informations like how internet is working and all. And like without these cables you cannot access any information. So it's a foundations, like the vital of our ecosystem for the development technology and all. And if I talk about like more in terms of technology point of view, then we have a foundation called as web solutions. So you can create a web solutions, right? So talking about specifically for the web solutions, it has a three core fundamentals. The first one is the website, like you can create a website with the help of HTML, CSS, and the JavaScript part. Right. So with the help of HTML, you can, create a structure of your web page. Like you can, create a meta tag, like the div tag, or maybe you can use buttons. You can apply CSS for the design part. And if you want to make more creative solutions like actions, like if you want to, create a functionalities where user will click on the button and then you can call some APIs, then you can use JavaScript. So each website have their specific, the page, which is called as, the name of your website, or in terms of technical way, we can say the domain of your website, the DNS. So you can create a website with the help of HTML, CSS, and the JavaScript part. And then we have a browser. So browser is just like as a computer, the program where you access the, the HTML, CSS, and the JavaScript code. So in simple way, the web browser is a software which is designed to, process the, the HTML, CSS, and the JavaScript code into the UI part. So in the market, there are multiple browsers, like you can use Chrome, Opera, or Safari, and there are multiple and number of browsers are available. So if I talk about the basic fundamentals, like you create a website with the help of HTML, CSS, and the JavaScript. So these, the file, or what we can say the code, will go to the browser, and inside browser there is a functionality called as rendering engine, which will render your HTML, CSS, and the JavaScript part into the UI, and then you will be able to see the final web page. So this is the basic fundamental. So if I talk about the open source ecosystem, like Google Summer of Code. So if you are participating in the Google Summer of Code, so you can also contribute into the the web browsers like the Chromium, or you can also use contribute into Chrome V8 engine. So I'll give you the simple example. So let's say if you're using Google Chrome, so we have a Blink as a rendering engine. So specifically for the JavaScript, they are using Chrome V8 engine. So if I talk about the Microsoft Edge, they have an Edge engine as a rendering. For the JavaScript, they are using Chakra. And for Safari, we have WebKit and JavaScript code for the JavaScript running the part. So this is just a basic overview, the fundamental, like the how the web ecosystem is working, and how you can access the information, how we can build the applications. And the third last part is like you can create a website, you can test your website with the help of browser. Now I want like my website will be accessible from the different network, different the devices. So for that we need a server. So server is just like as a computer where you can upload your HTML, CSS, and the JavaScript code into that particular PC, and you can connect with that particular computer with the network, and you can call this let's say XYZ IP, and then you can get the data like the files. So server is just like as a which serve the data to the browsers with the help of internet. So in the market we have a three types of server, like web server, email server, and the file server. So web server is specifically designed for serving of web pages, like you are using let's say HTTP, hypertext transfer protocol. That means we are accessing web server. Email server is more about like if you are sending emails, or if you are receiving an email, then we need an email server. So file server is more about like if you are downloading or uploading a file over the network, then you can use file server. So this is just a basic fundamental. So once you create the understand these kind of terminologies, then we can work on the web ecosystem part. So like let's say if I talk about as a student perspective, and I want to get started my journey as a web developer. So here we have a three tracks. You can be a front end developers where you just need to focus on the UI. You have a design, you just need to use the concept of HTML, CSS, and the JavaScript, and then you can create an interactive web pages or website. And if if you want to scale your knowledge into the front end technology part, then you can also use front end framework like Angular, Vue.js, React, and there are n number of frameworks that you can use for creating full stack front end applications. And then we have a backend part. Backend is more about like when user will click on the button, then there will be some business logic, like with the query will go to the database, or get the data from the database, and then we process some data informations and all. So for the backend, you can use any programming languages. But if I talk about the popularity point of view, then you can use JavaScript, Node.js, Python, PHP, and you can use any database because you have to work on the REST API or creating a backend business logic part. And then we have a full stack is more about like you have expertise in terms of front end, you have a expertise in the back end, then you can use, you can combine your expertise and you can be considered as a full stack developer. So here we have a multiple, the segments, like you can be a lamp stack developer, you can be a MERN stack developer, main stack developer, or mean stack developer. So this is more about, the technologies. Like if you are more comfortable with the Linux operating system ecosystem, then you can be a lamp. If you are more comfortable about the MongoDB, then you can, MongoDB, Express.js, Angular, and the Node.js, you can be a mean stack developer. So it's totally up to you, like how you can get started your journey as a backend developer or what against at the front end or the full stack developer. So once you, decided your journey, and then you can, get started your, app career in the the back end, front end, or web developer part. And but there is one more thing, like at the end, like we are accessing information, so we need to, store the information into a system. So for that, like we need a system, or we need a, what we can say, the information system where we can store the informations. So database is a terminologies where we can, store the informations, where we can apply some the operation in terms of, like, let's say I want to, add data or update data, read data, or delete data. So we can, store the data into a information kind of system. We can, apply some CRUD operations, and then we can, manage the data. So database is specifically, designed for system for information retrieval and managing the data in an easy way. So if I talk about, the basic, the architecture point of view, like we have a front end layer where you work on HTML, CSS, and the JavaScript part. And then we have a backend layer where you write the logic to collect the data from the database part. And in the database, you store the data. So you can store the textual data, you can store the numerical data, you can also store the binary file, you can also store, different data types. And, this is, the Persistent is more about, like you don't need to worry about the state part, you don't need to manage the states. The database is, once you store the data into database, your data will be there inside the database part. So in the market, like we have a two type of data. So first one is structured data in terms of, let's say Google Sheet or Microsoft Excel. So where we have a rows and the column. But if I talk about unstructured data means I don't know about the data type. I don't know about, the data frequency. I don't know the quality. I don't know the data, the types of data and all. So this is called as unstructured data. So let's say I'll give you the simple example. Let's say you are doing some transactions in the bank account. So this will be considered as a structural data. If I talk about unstructured data, let's say there is a bag, you are going for a trip for, let's say, Manali or maybe any XYZ country. So you put your t-shirts, your, pants, trousers, and multiple things. So there is no particular segment. So you just, put your, the dress, or let's say the clothes, into that particular bag, and you are not storing that particular information in a, the formatted way. So this will be considered as a unstructured data. So based on that particular data structure, or what we can say the structure and unstructured data, we have designed this kind of, the terminology called as SQL database or NoSQL database, or schema or no schema related database. So like if I talk about, like if you have a structured data, if you have a data in terms of rows and the column, then you can use structured database. So structured database, like you can store the data in terms of rows and column, and you can apply some queries, and then you can get the data, right? So in the market, there are multiple examples. There are multiple database in the market. Like if you have a structured data, and if you want to create a relations, and then you can use MySQL, or you can use PostgreSQL, or you can use like SQL Server. There are n number of database. Like you can use Google Sheet, you can use Google, like the Microsoft Excel as a database, as well as like, which is, the structured informations, right? And here you can, manage the asset properties. So asset is a basic fundamentals, like, like if you are in the college, or maybe if you have understand the basic idea about the database, then we can easily manage the asset properties like atomicity, consistency, integrity, and all. So like let's say that we have changed one data in a table, and then it will automatically update it. We don't need to update to multiple informations, the duplicate and all. And this is the relational database, or what we can say the structured database, is more important. Like if you have more relations in your data, relation in terms of, let's say, if you are creating applications like financial applications like the banking system, or maybe user related management system, user management, financial management. So there will be a lot of relations, like there will be a customer, there will be a manager. You can store the data into the MySQL database part. And then if you have unstructured data, unstructured, let's say we don't have a data type. I don't know about the data type, like which can be an array, can be an object, can be a string, or can be a number or a float part. So you can use unstructured database, like you can use MongoDB, Redis, Cassandra, Couchbase. And this is these type of NoSQL database is more suitable for if you have a, if you don't know about the product, if you don't have a idea about like the scalability, if you don't have a if you want to make a very flexible system, or if you want to do a horizontal scaling, means if you want to add multiple informations, then you can use NoSQL database. So these kind of the NoSQL database is good for, let's say, if you're creating an analytics kind of applications, if you are creating feeds in terms of like like the content writing platform, or real-time data related informations, then you can use these kind of unstructured database. So like this time, like here I'm going to talk about MySQL database part. Like this is more about like relational database, the system. So MySQL is the top most popular, the database in the world. Like if you are working on the structural database part. So here I have created this code lab. So what I do, I'm sharing a link. So you can open this link and you can, follow this particular, just a minute. Yeah. So you can scan this QR code, or you can just open this code lab. Let's wait for 2 minutes or 3 minutes. Okay, so this is the resources. So you just need to, open this code lab, just click on get started, and, follow these kind of steps, like step 1, 2, and step 3. So I'm not focusing on the fundamental part, like the writing of queries and all, because it's a AI generations. So you just need to go to the chat GPT or maybe Gemini, you can, understand the queries. So here I will talk about, the system designing part, like how let's say if I want to create a system like to do a kind of applications, so how we can create this kind of system through database, and what will be the functionalities that we can create architecturing and multiple part. So you can follow these code labs meanwhile. So like I'll give you the basic idea. Like if you have zero understanding about MySQL database, then we have to let's say if you have a data into MySQL database, then we need to retrieve the data. We need to apply some logics to get the data, or maybe delete the data or update the data. Then you can use the basic queries called as SQL, structured query languages, where with the help of SQL you can implement CRUD operations. You can filter the data, you can apply some aggregation logic, you can do multiple things. Like it's more about the thought process, like the prompt engineering for the LLM. So similarly, it's a SQL things for your SQL database. So like this is a simple example. Let's say if I have a data in my um, user as a table, so I want to pick name and email. So that's why I've written select name and email from user, where status is equal to active, and I want to get the data in a ascending or descending order. So you can define the order. And you can apply CRUD operations. Like if you want to add a data, then you can use insert queries. If you want to select the data or get the data, then you can use select queries. You can use star for collecting all the data. You can use update as a clause to if you want to update the data, then you can use update part. So this is the basic fundamental. Now I will talk about the basic, more the complex ecosystem. Let's say if you're creating a very applications where you have a multiple tables. So tables can be, let's say I have one table for the user, one table is for customer, one table is for orders, one table is for the product. And sometime we need to create a complex logic, like let's say I have some data in my the user table, I have a data in my order tables. So you can combine the tables, and then you can apply some the logical the reasoning capabilities. So for that we have a joins, like you can combine these two tables, and then you can apply the join can be, let's say, inner join, like the common data you can fetch. The lab join, like the lab intersection data. The full joins, like if you want to get the full data. And then you have a different type of joins mechanism, like it's more about the queries. So you just need to go to the documentations, and then you can get an idea about like outer join, left, inner joins, and all. And one more thing is more about like the normalizations, like whenever you are working on making SaaS applications, and then there will be a lot of data. So you define multiple tables. So now we need to work on the optimizations part. Optimization is just because of, let's say, you cannot store all the information in a single table. So what if we can break down the table into multiple sub tables, and then we can create a relations, and we can remove the duplicate the data. We can create a relations, we can create a foreign key, we can create a composite key, and then we can manage the relations like one to one, one to many, and many to many relations. So this is the basic the key capabilities that you can follow for optimizing the database part. And then there is one more concept called as scaling in terms of like the sharding part. So think like as a like YouTube. So let's say in YouTube there are billions of users, right? So we have, let's say, X amount of users in India, X amount of users in Singapore, X amount of users in Indonesia, and then Malaysia part. So let's say if you are storing all the users in a single table, and then if you are applying some queries, there will be some delay because data is too much, right? So we need to create a mechanism, so that like if we can divide the data into regional sections, or maybe you can divide the data into certain parameters part. So what if, like, if you have a central database, you can create a dedicated regional database, like let's say region one database, where you can store the information specifically for the Indian users. So let's say if I am in India, I'm accessing YouTube, then my information going to retrieve from Indian database, like where we have all the data specifically for the Indian customers. And same with the Indonesia, and same with the Singapore, or maybe same with the in the Malaysia part. So sharding is a concept where you divide the data based on certain parameters. So parameters you consider can be like you can define the one of the column, and then you can divide the database into multiple segments part, so that you can speed up your database. You can improve the performance and the logical capabilities and all. So now we jump to the simple use cases part. So what I'll do, I'm sharing one screen. So let's create a simple applications. So let's say if I want to create a simple SaaS application, like to do applications, like where we have a user will create a to do can be like task management system, like where user will create a name and then share the descriptions, right? And in the users we are storing information like username and email. Okay, so we have a two type of informations, like the user information, and we have a task related informations like the to do. So if you want to create this kind of the system, for that we need to figure out like what type of table that we can create. So let's create a table, let's say, for the users. So let's say I'm creating a table for users, where we have a the parameters, the columns. So first can be considered as a the id, which can be considered as a primary key, which is the uniquely identify individual row. And then you can define the another column is for, let's say, the full name, or you can mention the name. And the third one is the, let's say, email ID for that particular users. Okay. Then we need to manage the to do. So let's say if I go with the traditional way, so what we can do, we can create a to do like title. Let's say I'll add to do title, and then we can do file to do description, right? And then sixth one is more about like to do status, like like if it is done or not. So in the to do status, what you can do, store, you can store like complete, let's say pending, and let's say uh, complete or pending, let's say in progress, right? So like this is the just a basic, simple, like you can create this kind of table where you can store all the informations. But think like, let's say if you're creating a web application and you have this amount of your data. So let's say there is a one user, the username is let's say Ankit, and email ID is Ankit at the red wiki user group. And then we can store the informations like, yeah, create an event, and then description is create an event for like cohort 2, and the status is, let's say, pending. And then we have another same users like Ankit. So like you can uniquely, how we can uniquely identify the Ankit. So we can uniquely identify the Ankit through the email ID, or you can we need to normalize this kind of tables. So for the best practices, like what you can do, you can create another table is for to do, and then you can store this kind of information like to do's ID, individual ID, and then you can break down this kind of informations like and into to do table, right? So So here you store all the information related to do part. Here we are storing in independent informations of the users, and here we are storing independent informations about the to do. But how we can map the here user informations, like which to do is for which users. So here we need to add one more column. So you can mention the column name is user ID. So you can easily relate. Let's say I have a to do like create a travel plan for Singapore, and the username is or user ID is Vrijraj, or maybe 123, so that you can easily map the informations. Okay. And there is one more thing. It's a hard coded string. So hard coded string is more about like the complete, pending, and in progress. So what you can do, you can also create a separate tables like to do status. Right. So here you can also define the ID. You can also define the status. Let's say the label. So in the label, you can store these three value like the complete and these value here, and you can provide a reference as a ID, right? So this is a simple the example like how you can create a the complex simple logic in terms of relational point of view. And this will be more scalable because we have an independent the data for the user table, independent data for the to do, and inside to do table you can create a multiple entry for multiple users. And then inside to do status you can define the specific the value for to do status, because if you are storing the complete, pending, and in progress directly into the to do the table, and what if in future if you want to change the value, let's say complete to done, then you need to update multiple records. So what if you can share the reference as an ID, and then we can store that dedicated value into a different tables. So this is how you can design this kind of approach. So I would recommend, like, whenever you're working on any product development part, or whenever you're working on any SaaS application part, so first you need to identify the key entity.
So key identity in terms of like, let's say if I'm creating a to-do management kind of applications, there will be a two type of key identity, like the users and the to-do, right? So we can, then we need to figure out like what type of data we have. Is it like a structured data or is it like a unstructured data? So if it is structured data, then you can figure out like what type of tables that we can create. So let's say just go with the phase one, let's say version one you just mentioned. Let's say there might be possibility we can create three tables. Then you can, think like how we can, optimize three tables into, let's say, two tables or maybe five tables, so that we can create more complex, more scalable logic. So this is a kind of approach that you can follow whenever you are building, any full stack applications. And trust me, like, right now with the help of AI you can build any applications. But if I talk about, the architecturing the applications, like architecturing the full stack applications or the SaaS application, it's a very very tough task, because you need to focus on the database part, like how you can store the informations. Because if you have a large amount of data, and if you are providing, if you are, applying some query in a large amount of data, then there will be a lot of, delay in terms of, because if you have a large data, then there will be a lot of, the operational cost and all. So what if you can, create a data into, like, the chunks, like chunks in terms of subtables. Like you can create a relations, like you can create a one-to-one relations, you can create a one-to-many relations, or you can create a many-to-many relationship. So just focus on the use cases, identify the data structure, identify the type of entity, define the tables, and apply some mechanism like normalization capabilities like 1f, 2f, and 3f. And same with here, let's say in user and to do. So you can also apply the joins, like the inner joins. So you can also apply, different type of mechanism. Like if you want to, you can use aggregations. You can also use, the count as a queries to count individual users to do's. So you can apply these kind of logics. And like, I guess, like, that's all. Like this is more about, the basic fundamentals, like how we can, make it more scalable, the database. So point is like, just focus on the data, identify the use cases, and create an entity, define the tables, and just go with the version one, and then figure out like how we can, make it more, optimize the solutions using normalizations or optimizations strategies. Like if you have a large data, then you can use the concept of sharding. You can, use the concept of, the foreign key, primary key, and then you can follow those things. And talking about the resources, I would recommend, like, if you are a beginner, just focus on, the basic fundamentals. Just go to the SQL documentations. You can, get an idea about SQL queries, like how we can get the data, read the data, update the data, and all. And talking about the, the articles, I have also written a multiple articles for SQLs and scalability part, like the data sharding and all. So you can also check out those things. And then we have a code lab, so you can also check out the code labs for, the SQL. And there is one more code labs for, the SQL for PHP. So let me share link. Yeah. So this is the code lab. Like if you want to, access the, MySQL database through the PHP language, so you can also check out this code labs. And and feel free to connect with me over Instagram or, the LinkedIn and Twitter. So I'm happy to help you if you're building any SaaS or micro SaaS applications, if you're learning any tools, where you are using any database like SQL or NoSQL database and all. And you can also check out my website, vrijraj.xyz, and here you can see the information about the blogs, articles, and the code labs. And you can follow those code labs and the articles, and you can build the applications. And yeah, I'm looking forward to you to some, build some, cool applications with the help of database. So there is no specific, constraint. So I would recommend, like, just focus on the data, like what type of data you have, what type of relation you have. Then you can, figure out like whether we can use SQL database or whether we can use NoSQL database. And then you can, select any of the database. Like you can use SQL, you can, use PostgreSQL, you can use Microsoft SQL, or you can use unstructured database. And that's all. So thank you so much. And I'm open for the questions. So if you have any questions, so feel free to connect with me. And yeah, it's time for the questions.
Cool. Guys, if you have any questions, please put it in the um, chat. We will take it. The chat is 1 minute delay, so it will take some time. If you have any questions related to databases, SQL, or full stack, feel free to drop it in the chat box. So we have a question from Vishwash, who said, how to select which database is the best for an application.
Again, so like as I said, like first focus on the data. Like let's say if you're creating applications like social media kind of applications, so you need to identify like what type of data will we will use that particular the social media things, right? So let's say you can identify the entity, you can also identify the relations, like if it is do we have any more relations like one to one or one to many, or if you have any unstructured data. So you can based on that particular use cases, then you can decide the database. Because right now in the market, or not even in India, but if you go to the abroad or different countries, so right now like people or as a developers, we directly jump to the NoSQL or maybe MySQL database. But rather than focusing on the problem statement, like what type of problem they are solving, because in the future they will face the challenges like we cannot make the relations in our data, we cannot create a you know to make more scalable solutions because we need to shift to the different database. So that's why like I recommend just do some POC about the data entity and the relations and the future aspect of your features, and how you can connect the data points, then you can decide the database and all. Any other questions?
So we have a question: how does a backend application actually talk to a database?
Okay, so what I'll do, I'll sharing my screen. Okay. So if I talk about the basic understanding of the ecosystem, so in the backend, like whenever you are working on a backend development part, so you need us, for the backend, we need a like the terminology called as server, right? So server, which is equal to let's say window or slash PC, right? So in the Windows, we can, store, we can install any operating system, right? So in this particular operating system, you can install any database. So let's say I'm using MySQL, or if you're using any other database, so in that particular server, you can install the database. It's totally up to you what type of data you wanted to use. And in the backend, you need to write a script in terms of the logic, or what we can say the backend logic. So you can write a backend logic in a Node.js. You can use the TypeScript. You can use JS, or you can use Python, right? So here you can write the logic to collect the data from MySQL server and share the data to the browsers. The browser is here. So this is the basic communications. So you need to write a backend logic. So whenever you're working on a backend development part, so you need to work on a server side, or what we can say the backend side, where you need to write a script, you need to write a the backend logic. You can read any programming languages, and inside the backend you can use that particular database. Any other questions?
We have a question from Rohit. In which cases do we think we should actually use one of AWS provider database engines? In general, how do we know how large of a database our machine might require?
Okay, so like each database have a restrictions, so you need to understand the limitations. Let's say if you're using MySQL database, so inside in the MySQL database you can create maximum up to, I guess, like 4,000 column. So after 4,000 column you cannot create a, like you cannot more column. So this is concept called as horizontal scaling. So think like as a Google sheet or maybe Microsoft Excel sheet, there will be a multiple columns. So there is a limitation, like after let's say X amount of column you cannot add multiple columns. So this is how you can need to calculate your, the scalability. So what type of parameter you have, based on that particular parameters you can, decide the complexity. And talking about the cloud ecosystem, so each cloud service will provider have created their own, the customized SQL database. So customized SQL database is more about like they have added, two three more functionalities like auto backup, auto scaling, auto horizontal scaling. So if you go to the AWS, they also provide, SQL database. If you go to the GCP, they also provide a cloud SQL database. If you go to the different, the service provider, they also provide a different type of SQL database. But they have a different, the type of capabilities, the limitations and the features. So you just need to go to the documentations and you can understand the capabilities, and then you can decide. And talking about the scalability part, like you cannot, predict the scalability, but what you can do, you can do some, the POC, the case studies, like what type of data you have, and what will be the future aspect for your features, and how we can, get the large amount of data and all. Okay, so another question is more about database sharing part. So there are multiple, the online database. So if you are working on, what we can say the SQL database, there are multiple, the SQL's online provider where you can host or deploy the database, and then you can, share the database URL, and then you can share the, the credentials, and you can access that particular database. So there are multiple, the database providers. So you can use Superbase. Superbase is providing a free of cost SQL database. Like they have a PostgreSQL, which is similar to the MySQL database, but they have additional capabilities. So you can, search online free, SQL database, and you can create a credentials, and then you can access those, the database, and you can share the database with your friends while working on multiple, teams and all. So yeah. So another question is you can add someone. Yeah. So there is one more question is more about the Prisma. So Prisma is more about like what we can say the C++ language. So object oriented programming language. Like if you are in the first year, then you will get to know about the C programming languages. After that we have the object oriented programming languages. Like whenever we are creating a program, we will identify as an object. So every entity can be considered as an object. So similarly, like if you are creating an operations, or if you are writing an operations, like let's say this arrow, let's say red color arrow, like I'm communicating with the database, right? So I need to write some logic, I need to write the queries, right? So they have a different mechanism. Like you can use native queries, like select star from my database or columns or something. So you can use native query. Otherwise, like you can use object relational modeling part, like it's a ORM. So ORM is more about like object level, the mapping. So you can define the tables as an object, and then you can call the functionalities directly, like create, read, and delete part. So Prisma is one of the, the ORM for your SQL database. Same way we have SQLized, there are multiple, the ORMs. So you just need to, it's a kind of drivers, like they can give you the top of the, the quality. Like if you are creating a very large scale complex applications where you need to write a, the backend logic to collect the information through the database, then you can use ORM, like the complex logic, object oriented informations and all. And each type of database like MongoDB or let's say PostgreSQL, Cassandra, and multiple things, you just need to search ORM. So you can work by that particular ORM with your the programming languages part. And another question is more about the prompt injections and malicious SQL queries. So, there are type of, the multiple attacks like XSS attack. So what you can do, like you can, normalize the, sanitize the informations, like whatever the SQL queries is going on. So you can sanitize the queries, like sanitize in terms of, so you have some case sensitive informations. Let's say, if user is passing this kind of information, so let's say alert, and ABC, and let's say I'm storing this kind of information into my database. So for the best practices, you need to sanitize the queries. Sanitize is more about, like, you cannot store that this kind of information directly into your database. So if you have any specific character, so you can transform this specific character into different type of the parameter, and then you can store the informations. Because once you store directly these kind of informations, this can be a script, this can be a malicious, the injections kind of activities. So they can execute directly into a database, and then it can create some threats and security issues. Any other questions? Yeah, so again, like, there is a limitation, so that's why, like, like, we have C language, we have C++. So, like, if you are using MySQL database and if you are using PostgreSQL database, so we have a top of the features. Like, if you are dealing with the JSON data, so that's why, like, if you are dealing with the outer joins related issues, so I would recommend, like, go with the PostgreSQL database because they have more capabilities. Yeah, any other questions? Yeah, I guess, like, that's all from my end. Thank you so much, and feel free to connect with me over social media or LinkedIn. And yeah, which database would be more compatible for the Flutter? Again, like, we have a different type of database. Like, we have also on-device database. On-device is like there is a light version of your database that you can directly access in your mobile devices, like SQLite or any other type of database. So again, like, if, I would recommend, like, use create an API and use connect the API with your database into the server, and then you can use those things. Otherwise, like, you can use SQLite, or you can also use in-memory database data as well as. So we have a different type of the strategy and all. You can use anything like in React Native. Honestly, you just need, for the best practices, I would recommend create an API and use the API directly into your the front end applications for the security point of view. Do not interact directly with database into your devices through the front end and all, because you can create a layered architecture for the security purpose. Like, you can create a middleware, and then you can create some mechanism for filtering your users or unauthorized user part. Okay, so that's all from my end. Thank you so much, Ankit, for having me, and yeah, looking forward to you all. Yeah.
Yeah. Thank you, Vrijraj, for joining. Guys, if you have any questions, we can take it. You can take it to Vrijraj on LinkedIn maybe or Twitter. But yeah, thank you so much, Vrijraj, for joining. I think they have learned a lot of things on databases, on SQL, on full stack. So if you have any questions related to startup, Vrijraj is also a part of that Google for Startup. If you have any questions related to that, you can ask to Vrijraj. Yeah, cool.
Yeah, thank you so much.
Cool. Guys, we have sent you email where we have sent you ask you to put your username to us so that we can also see what your contribution is. So I will ask Abby to put that in the chat box so that you can again fill up the form. The last date is tomorrow, so please fill up the form by last tomorrow so that we also have this information. I've also put that on WhatsApp group. Good. So let's come to the part two, which is really short. We are short of time, so we will be heading towards part two. For this databases, how Wikimedia uses, we will be doing another detailed call on Wikimedia SQL and MariaDB, how we use these databases. But right now, let me give you a small overview of that. You might have heard of edit button on Wiki ecosystem. So in early days, from 2001 to 2004, Wikimedia was very small. There was one main server, one databases. So went at night when the traffic increases, the website used to be slowed down and even crashed. So what they did, they realized something important. Reading is 1000x more than writing. So they have find out these things that we have more people who are just reading rather than writing. There are millions of read and only few edits. So instead of using one database, they created one master database only for edit and many replicas of that database only for reading. So now what this happens, editor talks to the master database and reader talk to the replica database. So this is how they have managed to um, do this. Second, let's talk about um, the second use case that we follow. Even with replicas, popular pages like India, World War II, Donald Trump were opened million of times daily. So the databases were still being asked the same question repeated times. So we introduce a caching tool. So feel free to research more on caching tools. We have used varnished cache and Redis for this, where it saves small data and sessions. And now instead of rebuilding the entire page every time, Wikipedia just serve a saved version in in milliseconds. So this is how it happens, and the speed of the ecosystem increases significantly. And the second part is elastic search on the search. So user have complained that the search is slow and inaccurate. So we have added elastic search. It's a powerful search engine so that it becomes instant and smarter. And the last part is about global search. So you might have asked this question on your user form to send us a global account. So traffic, something similar. The global search works. Traffic came from every country. If everyone is connected to one country server, latency was huge. So we have used CDN for that and multiple data center worldwide. So we have few data centers in Singapore, few in US, not in India as of now, but after taxes might be a chance. After tax holiday might be a chance for that. So after doing this, pages start loading fast everywhere. So this is how we have uses databases smartly in our whole ecosystem. Cool. So that's all from us, guys. Thank you for joining. We will be doing another session in the next week. I will be communicating with the same over email. So feel free to ask your doubts. I will be sharing some resources over email related to SQL, related to databases. So you can continue doing that. If you have not created your SSH keys, please do that, because you need to fill up the form, and it's very important that you have a SSH key, because on the next uh, part of this project we will be pairing with you mentors with a mentor, and they will be helping you to merge a task. So please set up your SSH keys. If you have any questions, you can put it in the um, group. It's all about peer learning and helping each other. So yeah, thank you guys for joining.